You close the door on a cold winter day, grateful for the warmth of your modern home. You have got the double-glazed windows, the thick insulation, the heating system that keeps the cold out. But as the weeks go by, you start to notice it, that musty smell in the bedroom, black spots in the corner of the bathroom, water weeping down the inside of your windows. It is mold, a house guest you never invited, and one that seems impossible to get rid of. You follow all the advice. You open the windows, you wipe it down, you buy dehumidifiers, and yet every winter it comes back. How is this possible? What did builders from the Middle Ages know that we have catastrophically forgotten? It is not magic, it is science, a forgotten science of moisture, materials, and air that our ancestors mastered. And in the next few minutes, we are going to uncover the secrets that allowed their buildings to breathe, and why our desperate attempts to save energy might have turned our own homes into sealed, damp traps. Before we dive into these secrets, I want to hear from you. Have you battled mold in your home this fall? Drop a comment with your biggest moisture problem right now. Section 1. The Modern Problem. The story of our modern mold problem begins with a really good intention: energy efficiency. Spurred by the energy crises of the 1970s, we declared war on drafts. We started building our homes to be as airtight as possible, wrapping them in plastic and sealing every single gap. The goal was to create a thermos, a sealed box that holds onto every bit of heat. On paper, it is a brilliant idea. In reality, we accidentally created a pressure cooker for moisture. Think about how much water vapor a typical family produces in one day. We breathe it out. We release it when we shower, cook pasta, dry our laundry. In an older, draftier house, this moisture had countless ways to get out through leaky windows, gaps in the floor, and porous walls. But in our modern airtight homes, it has nowhere to go. So, where does it end up? It moves towards the coldest surfaces in your home. This is just a basic law of physics. Moisture goes from warm, high-pressure areas to cold, low-pressure areas. In winter, this means the vapor from your hot shower travels until it finds a cold spot, like the wall that faces the outside, a corner of the ceiling, or your energy-efficient window. When that warm, moist air hits that cold surface, its temperature drops to the dew point. At that exact moment, the vapor condenses back into liquid water. You can see it as droplets on your windows, but it is also happening invisibly on your walls, and that is when the real trouble begins. The materials we use in modern homes are a feast for mold. Drywall, with its paper facing, is a perfect food source. Add the moisture from condensation, and you have created the ideal resort for toxic black mold. We have wrapped our houses in plastic vapor barriers and painted them with impermeable coatings, all to be more efficient. But in doing so, we have built the perfect mold-making machine. We stopped our houses from breathing, and now they are slowly suffocating. The irony is brutal. The very features you paid more for, the airtightness, the superior insulation, are exactly what might be making your home sick. Section 2. The Science of Breathing Walls. So if our modern approach has created this damp crisis, what was the alternative? To answer that, we need to go back centuries, to a time before plastic and before the idea of an airtight seal even existed. Medieval builders did not have PhDs in building science, but they had something more valuable: generations of experience. They knew that to fight dampness, you do not block it, you manage it. Their solution was not to create a perfect barrier, but to build walls that could breathe. Now, let us be clear. It is not like medieval homes were magical structures that never got damp or moldy. Ancient texts even describe processes for dealing with plagues in a house that sound a lot like mold removal. However, the systemic trap moisture condensation that rots our modern homes from the inside out was far less common, because their entire building system was designed to be vapor permeable. The core of this forgotten wisdom is a simple concept: hygroscopicity. It is the ability of a material to absorb moisture from the air when it is humid, and then release it back when the air is dry. Think of it like a natural, built-in dehumidifier. Medieval homes were built almost entirely from hygroscopic materials. Instead of our gypsum drywall and plastic paint, they used timber, earth, straw, and, most importantly, lime. A medieval wall acted like a giant, clever sponge. When the family inside was cooking or just breathing on a cold night, the interior wall would absorb that extra humidity, holding it inside the material itself. This helped keep the humidity in the room at a more stable level, often buffering it into a range that is less hospitable for most molds. Then, when the air became drier, the walls would slowly release that stored moisture back into the room or to the outside. This constant slow-motion breathing prevented the sudden drop in surface temperature that causes condensation in our homes. The moisture never got a chance to pool as liquid water, which is the trigger for mold. We see our walls as static, dead barriers. For a medieval builder, a wall was a living, breathing part of the home's ecosystem. This is the fundamental secret we forgot. A wall should not be a raincoat. It should be a wool coat. A raincoat traps sweat and makes you wet from the inside. A wool coat, however, breathes, absorbing moisture and moving it away to keep you dry. Our modern homes are wearing raincoats. Medieval homes wore wool. Section 3. Earth floors. The foundation that breathes. We have talked about breathing walls and breathing roofs, but medieval builders understood something we have completely forgotten. The floor must breathe too. Medieval earth floors were not just primitive dirt. They were carefully constructed layers of compacted earth, often mixed with lime, oxblood, or linseed oil to create a hard, durable surface. And unlike our modern concrete slabs with plastic vapor barriers underneath, these floors were active participants in moisture management. Research from the Danish Technical University shows that the first 10 millimeters of an earth surface provides most of the moisture buffering capacity. When indoor humidity spikes from cooking, breathing, or bathing, the earth floor absorbs that excess moisture. When the air dries out, it releases it back. This created a stable humidity range of 40 to 60%, the sweet spot where mold struggles to grow, but humans remain comfortable. Modern concrete floors do the opposite. We pour concrete directly onto plastic sheeting, creating an impermeable barrier. Any moisture that gets trapped under that concrete has nowhere to go. It either pushes up through cracks, creating efflorescence and damage, or it forces all that moisture into the air, where it condenses on cold walls. Medieval builders knew the ground was naturally damp. Instead of fighting it with barriers, they used materials that could manage it. The floor was not a lid, it was a valve, constantly regulating moisture flow between the earth below and the air above. Secret 4. The mathematics of breathing. If medieval walls were designed to breathe, modern walls are designed to do the exact opposite, and the component most responsible for this is the vapor barrier. This is perhaps the single biggest blunder of modern building science. First, let us understand what it is supposed to do. A vapor barrier, usually a sheet of plastic, is installed in a wall to stop water vapor from passing through it. The idea is that in a cold climate, you stop warm, moist indoor air from getting into the wall cavity where it could condense and cause rot. The theory is sound. The execution is often a catastrophe. Here is the math that medieval builders understood intuitively, even without numbers. Medieval lime plaster has a vapor permeability of about 15 to 20 perms. Modern plastic vapor barriers? About 0.1 perms, that is 150 to 200 times less breathable. The rule that governs moisture-safe construction is this. The warm side of the wall needs about 5 times more vapor resistance than the cold side. This creates a pressure gradient that pushes moisture outward, where it can safely evaporate. Medieval walls achieved this naturally. The interior lime plaster was slightly denser than the exterior, creating that 5-to-1 ratio without any plastic. But modern vapor barriers create infinite resistance on one side. This sounds good until you realize buildings are not perfect. Moisture gets into walls from all directions. Rain can get in through tiny cracks. A small plumbing leak can go unnoticed. In an old breathable wall, this moisture could dry out. But in our modern wall, we have created a trap. The plastic vapor barrier on the inside prevents it from drying inward. Modern exterior wraps can prevent it from drying outward. The moisture is now trapped inside the wall cavity. It soaks the insulation, making it less effective, and seeps into the wooden studs. This creates a dark, damp, stagnant environment, the perfect incubator for mold and rot, hidden from view. Problems with modern vapor barriers are a leading cause of moisture-related building failures. You will not see it until you smell that musty odor or see the paint bubbling, and by then, the damage can be huge. Medieval builders never used plastic, but they understood the physics. Their walls were vapor open, meaning they could dry in both directions. Moisture could move freely through the wall, ensuring that no single part stayed wet for long. The great blunder was not the invention of the vapor barrier, but the belief that we could create a perfect impermeable seal. In our quest to control moisture, we created a system that can fail catastrophically, while the primitive medieval wall, designed to go with the flow, has been successfully managing moisture for centuries. If this is blowing your mind like it did mine, hit that like button. It helps more people discover these forgotten secrets. And stick around, because the next part about medieval fireplaces will change how you think about heating forever. Secret 5. The wisdom of leaks and drafts. In our modern world, we see a draft as a failure. A gap under a door is an inefficiency to be sealed immediately. But what if those defects were actually part of an incredibly simple yet effective ventilation system? Medieval buildings were, by our standards, very leaky. Windows were often ill-fitting wooden shutters. Doors swelled and shrank with the seasons, leaving gaps. And this, it turns out, was a critical part of their success. This constant low-level air exchange, what we call passive ventilation, was the building's respiratory system. It ensured that the damp, stale air from breathing and cooking was continuously being replaced by fresh, drier air from outside. This process of natural ventilation was a key strategy in historic buildings for preventing the buildup of humidity that leads to mold. It stopped water vapor from concentrating to the point of condensation. The very design of medieval homes also played a role. The irregularity of the construction and the smaller rooms often prevented the stagnant cold corners that are notorious mold hotspots in our homes today. Here is the geometry that matters. A medieval room was typically 12 feet by 12 feet with an 8-foot ceiling. That is 1,152 cubic feet of air to heat. Modern open concept living, a 20 by 30 foot space with 10-foot ceilings, is 6,000 cubic feet. That is 5 times more volume, where moisture can accumulate in corners, where air movement is weakest and temperatures are coldest. Medieval builders knew smaller rooms mean fewer cold spots, faster air turnover, and easier to keep every surface above the dew point. Every corner could feel the warmth of the fire. Every wall could dry between moisture events. Our obsession with airtightness has eliminated this free, automatic exchange of air. We have built our homes so tightly that without expensive mechanical ventilation systems, the indoor air gets trapped, the humidity climbs, and the environment becomes ripe for mold. We sealed the drafts, and in doing so, we sealed in the problem. Of course, no one is suggesting we go back to living in uncomfortable, drafty houses. But there is a profound lesson here. Medieval builders understood that a building needs to ventilate to stay healthy. They achieved it through what we see as imperfections. Our challenge is to relearn that lesson and find modern, intelligent ways to make sure our homes can breathe. Secret 6. The central hearth and smoke evolution. At the heart of almost every medieval dwelling was the fire. But the central hearth was so much more than just a source of heat. It was the engine of the entire building, a multifunctional device for warmth, light, cooking, and most crucially, a powerful dehumidifier. In early medieval homes, the fire was often just an open hearth in the middle of the room, with smoke finding its way out through a hole in the roof. This created a constant, powerful upward draft of hot air, known as the stack effect. This rising column of hot air acted like a massive exhaust fan, continuously pulling air from the living space up and out. And with that air, it pulled out a huge amount of moisture from cooking, breathing, and drying clothes. This passive ventilation system was incredibly effective at managing indoor humidity. But the system evolved. Medieval builders were constantly innovating. By the 12th century, timber-framed buildings introduced the smoke bay, a sealed-off section of the building where smoke could accumulate before escaping through louvres in the roof. This gave more control. By the 13th century, stone smoke hoods appeared, suspended over the hearth, channeling smoke more efficiently. Finally, by the 14th century, the chimney as we know it, a vertical flue built into the wall, became widespread. Each evolution improved moisture control. The chimney was not just for smoke. It was a 24-hour ventilation shaft, pulling stale, humid air out of the house, even when the fire was low. But the fire's role did not stop there. The radiant heat it produced warmed the very structure of the house, the stone floor, the thick walls, the timber posts. This is a critical difference from our modern central heating. Our systems usually heat the air, which often leaves the walls and other surfaces cold. This creates the perfect conditions for condensation. A medieval hearth, however, heated the thermal mass of the building. By keeping the surfaces of the building warm well above the dew point, it made it physically impossible for condensation to form on them. And here is something we have completely forgotten: animals as living radiators. Medieval households often kept cows, goats, or chickens inside the home or in a room with a shared wall. A single cow produces about 1,000 watts of heat continuously, equivalent to a space heater running all day. That heat rose naturally into sleeping lofts above. Yes, there was smell, but the ventilation system we just discussed handled it. The medieval home was not just a building, it was an integrated thermal ecosystem. This combination of active ventilation from the stack effect, thermal mass heating, and biological heat sources was an incredibly effective system. So when we replaced the central fire with radiators and sealed up the chimneys, we did not just change how we heat our homes. We accidentally shut down our home's most effective dehumidification system. Secret 7. The power of hygroscopic material. While the design of medieval buildings was clever, the true genius was in the materials themselves. Let us dive deeper into the science of two of them, lime and clay. They are the polar opposite of our modern gypsum drywall and plastic-based paints. The champion of historical building materials is lime, used in plaster, mortar, and lime wash. Lime is exceptionally breathable or vapor permeable. Unlike modern cement mortar, which is dense and waterproof, lime mortar lets water vapor pass through it freely. This meant a wall could easily dry out after being soaked by rain. Second, lime is naturally antimicrobial. Because of its high alkalinity, a pH of around 12, lime plaster creates a surface that is actively hostile to the growth of mold and bacteria. While not completely mold-proof if it is always wet, its inherent properties provided a powerful first line of defense that modern drywall just does not have. And like clay, lime is hygroscopic, helping to regulate indoor humidity. But here is what medieval builders did annually that we have forgotten: lime wash. Every spring, they would apply a fresh coat of lime-based whitewash to both interior and exterior timber frames. This was not just decoration, it was active maintenance. The lime wash filled microscopic cracks caused by seasonal wood movement. It provided a renewable antimicrobial coating. It reflected UV light, protecting the wood beneath. And because it was breathable, it never trapped moisture behind it like modern paints do. And then there is the genius of sacrificial mortar. Medieval lime mortar was intentionally softer and weaker than the stones or bricks it held together. This seems backwards until you understand the principle. When a wall moves, and all walls move with temperature, moisture, and settling, something has to give. In a medieval wall, the soft lime mortar absorbed that movement, cracking or crumbling instead of the stone. And because lime mortar is more porous than stone, it also attracted moisture and salts out of the masonry and into the joints, where they could evaporate safely. The result? Replace the cheap mortar every 50 years. The expensive stone lasts 500 years. Contrast this with modern cement mortar. Cement is harder than most historic brick or stone. When movement occurs, the rigid cement forces cracks into the masonry itself, and because cement is less porous, moisture cannot escape through it. Instead, the water is forced to evaporate through the face of the stone, carrying salts with it that crystallize and cause the stone's surface to crumble. This is why you see old buildings repointed with cement where entire faces of stones have been lost, but the hard cement pointing stands proud. It is backwards. The cheap component became permanent and the expensive component became sacrificial. Now contrast this with a modern wall. We use gypsum drywall, which is basically gypsum plaster between two sheets of paper. The paper is an ideal food source for mold. Then we cover it with acrylic or vinyl-based paints, which form a plastic-like film on the surface. This film is largely non-breathable and can drastically reduce a wall's natural ability to buffer moisture. Studies show that painting plasterboard with vinyl paint reduces moisture buffering by 80%. So the modern approach is to take a material that is susceptible to mold and seal it with a coating that stops the wall from breathing. The medieval approach was to use materials that are less hospitable to mold and let the whole wall breathe. One system is designed to fail catastrophically. The other was designed to manage moisture as a matter of course. Secret 8. The intelligent roof. When we think of a thatched roof, we usually picture a quaint cottage, not a high-performance building material. But the truth is, a properly made thatched roof was a marvel of engineering, a super-insulating, breathable system. The insulating power of thatch comes from trapped air. A thick layer of thatch is not a solid mass. It is a dense matrix of millions of hollow stems with countless tiny air pockets. This trapped air is an excellent insulator. How well does it insulate? A standard 12-inch thick thatched roof can achieve an insulation value of R35 to R40, often comparable to or even exceeding what is found in many standard modern roofs. It keeps the building warm in winter and cool in summer. But here is where the thatched roof reveals its true genius. Unlike a modern roof, it is highly breathable. Water vapor rising through the house can pass straight through the thatch and into the atmosphere. This prevents a huge problem common in modern attics: condensation. In a typical modern home, warm, moist air can leak into the cold attic and hit the ice-cold surface of the roof deck, causing damp insulation and rot. A thatched roof avoids this entirely. Because it is vapor permeable, there is no surface for condensation to form on. The moisture just passes through. A well-maintained water-reed roof could last 40 to 50 years, all while providing great insulation and foolproof moisture management. It was an intelligent system that worked with the laws of physics, not against them. Secret 9, please, bringing medieval wisdom into your modern home. So, after this journey back in time, the question is, what can you do with this knowledge? You are not going to tear down your drywall and replace it with wattle and daub, but the principles behind these techniques are timeless, and they offer a clear roadmap for a healthier home. First, and most importantly, ventilate, ventilate, ventilate. The medievals had it by accident. We have to do it on purpose. The simplest method is the oldest. Open your windows. Try to open windows on opposite sides of the house for just 10 to 15 minutes every day, even in winter. This creates a cross flow that purges moisture, and always use your extractor fans in the kitchen and bathroom. Second, think about geometry. Pull large furniture away from exterior walls. Just a few inches allows air to circulate and prevents trapped cold spots where condensation loves to form. Third, rethink your heating. Instead of blasting the heat for a few hours, try to maintain a lower, more constant background temperature. This helps keep the surfaces of your home warmer, reducing the risk of condensation. It mimics the effect of that old central hearth, which provided steady warmth to the building itself. When you redecorate, consider using modern breathable paints like mineral-based or silicate paints. They let walls breathe while still providing protection. Avoid vinyl or acrylic paints on old walls. Use a dehumidifier strategically. Place it in moisture-generating rooms like bathrooms or bedrooms. It is basically an electric version of what those old hygroscopic walls used to do naturally. Manage moisture at the source. Make sure your clothes dryer vents to the outside. Avoid drying lots of laundry indoors on racks. If you have to, use a single room with a window cracked open. For bigger projects, look into clay or lime plasters. They are making a comeback for a reason. If you are renovating a pre-1920 building, do not add plastic vapor barriers. These old buildings were designed to breathe. Sealing them kills them. Never do this. Never paint historic lime plaster or brick with modern vinyl or acrylic paint. You will seal in moisture and cause damage. Never add vapor barriers to walls in buildings constructed before 1920. Never seal a historic building completely airtight. It needs to breathe to survive. Finally, understand your home. Be vigilant about maintenance. A small leak in the roof or a crack in the siding can let in moisture that your sealed-up walls cannot get rid of. The core lesson from our ancestors is not that their buildings were perfect, but that they were resilient. They were designed as a complete system that knew how to manage moisture. They understood that a house must breathe, and by applying these ancient principles, we can start to undo the unintended consequences of our modern building methods and help our own homes to finally take a deep breath. Finally take a deep breath. Finally take a